Today we're going to take a look at the roots of complex numbers. Now we talked about roots of polynomials early in the year. That was chapter 2. And we saw that there was a relationship between the degree of a polynomial and the number of roots that that polynomial had. And in fact, those two things were equal. So if we had a function of degree 7, that function had 7 roots. So a function like x to the 6th minus 1 should have 6 roots. So if we go about solving this algebraically, we would set our function equal to 0. We get x to the 6th equals 1. And then if we take a 6th root, we would have plus or minus 1, because 1 to the 6th equals 1, but also negative 1 to the 6th equals 1. But that's only 2 roots, a positive and a negative. There should be 4 others because we have x to the 6th power. So the 4 others must be complex roots. So today we're going to go about looking for those complex roots. Okay, so here is our formula for roots of complex numbers in trig form. If we have a complex number, r cis theta, the nth root of z can be found by taking the nth root of r cis, and now we're going to play around with theta a little bit. We're going to do theta plus 2 pi k over n. N is the root, right? We're taking the nth root. Here we're dividing the angle by n. Now k is some constant, and k starts at 0 and is always a whole number. And it's going to end not at n, but at n minus 1. So let's look at an example problem to see what this looks like numerically. Although I do want to point out that I wrote this in radians. This term right here, if we're working in degrees, would be 360 k. So let's say we wanted to find the square roots of this number. This is z equals 16 cis 60 degrees. Well, there should be 2 square roots. So n is 2. We're going to have 2 answers to this question here. And the way we find them is we assign values to k. Now first we start with k being equal to 0. And we're just going to plug in like the formula you saw on the previous page. So we're going to do radical 16, the square root of 16, cis. We take the angle plus 360 times k all over n, and n is equal to 2. So that simplifies to be 4 cis. This is 0. 60 divided by 2 is 30 degrees. But now we do this again for k equal to 1. Square root of 16 cis, 60 degrees plus 360 times 1 over 2. We get 4 cis, 210. So here we'd have 60 plus 360 is 420, divided by 2 gives us 210 degrees. So these are our 2 square roots, 4 cis 30 and 4 cis 210. What this means is if we square both of these numbers, we should get 16 cis 60. So let's see. So we're going to have 4 squared, which is 16, cis. We multiply the angle by the power. 30 times 2 is 60. So that worked out nicely. Here again we have 4 squared, cis. 210 times 2 which is 420. And let's see, 420 minus 360, we're finding a coterminal angle between 0 and 360, is 60. So that's equal to 16 cis 60 also. So that's one way to check yourself once you find your roots, is to raise the roots to the power and see if you get the original number back. Now just be careful of the directions. I'm leaving my solutions here in trig form. Make sure you read the directions when you do your homework or on a test, because it may say that you should leave them in standard form, in which case you want to convert your solutions. So let's look at another example. Let's find the fourth roots of 625i. So in this case, n is equal to 4, which means that k will start at 0 and go up to 3. Now notice that this here is in standard form. We want that to be in trig form in order to use our formula. So let's convert that. This number is, it's really 0 plus 625i. We need the radius. That would be 0 squared plus 625 squared, which will just be 625. And our angle is going to be 625 over 0. So this is undefined. So where is tan theta undefined? Well, that can happen at pi over 2 or 3 pi over 2. But if we think about where this number is, if we plotted it, it would be along the positive y-axis. So this is out. Our angle is pi over 2. So the number we're dealing with is z equals, what's our radius? 625 cis pi over 2. So that's your first step, is to write your number in trig form if it isn't given to you that way. Okay, so we're working with 625 cis pi over 2, and we are looking for the fourth roots. So we're going to start with k equals 0. We're going to take the fourth root of 625, and then we have theta plus 2 pi k all over n. So the fourth root of 625 is 5, cis. This is gone. We've got pi over 2 over 4, so that is pi over 8. So that's one of the fourth roots of z. We can find the next one by allowing k to be 1. Again, fourth root of 625, cis pi over 2 plus 2 pi times 1 over 4. So that is 5 cis. We've got pi over 2 plus 2 pi, that's 5 pi over 2 over 4, which is 5 pi over 8. K equals 2. The fourth root of 625 cis pi over 2 plus 2 pi times 2 over 4 is 5 cis. So now what do we have? We've got 4 pi plus pi over 2. That's 9 pi over 2. So 9 pi over 2 over 4 is 9 pi over 8. And the last one, fourth root of 625 cis pi over 2 plus 2 pi times 3 over 4, 5 cis. So this is 6 pi plus pi over 2. That's 13 pi over 2. And 13 pi over 2 over 4 is 13 pi over 8. Now, I'm not going to do this right now with you, but if we raised each of these numbers to the fourth power, we should get 625 cis pi over 2. So here's our summary. In order to find the roots of complex numbers, you first need to make sure that your number is in trig form. So you may have a conversion to do. Then, given our number in trig form, we find the nth roots by taking the nth root of r, and then we add to theta 2 pi k over n, where k begins at 0 and ends at n minus 1. And again, make sure you read the directions so that you know whether you should leave your answer in trig form, like I did in this video, or if you should convert them back into standard form.